Okay, I have a problem with my brain. I'll get an idea that's maybe a little ambitious. I'll start reading, I'll start writing, I'll fall down some rabbit holes. I'll learn things like we don't know what soot is beyond carbon, mostly. And then it'll have been several months since the last video. But that's okay. I'll make the next one even better to compensate. And then I'll do more reading, more writing, fall down more rabbit holes. And then I have a script that would be an hour long, and it's been over a year. And I have done this 3 times. 3 different subjects. So today, I'm going to stop, I'm going to take a deep breath, and talk about something less complicated. And it doesn't get much less complicated than this. Hello! Today, we're going to talk about PARcans. The PARcan is a PAR lamp in a can. PAR stands for parabolic aluminized reflector, because the reflector is a parabola that's coated in shiny aluminum. The can part is literally just an open tube. There's some bracketry in here to hold the lamp in, and there's supposed to be a grid to catch any pieces if the lamp explodes. Technically, this lamp is a PAR 64. The number is the diameter of the lamp in 1/8 of an inch, because of course it is. So a PAR 64 is 8 inches in diameter. A PAR 56 is 7 inches in diameter. And adorable. The connector is an extended mogul end prong, because early connector names were also ridiculous. The PAR 56 has just the plain mogul end prong. These look like you could just plug them into an American electrical outlet, but do not do this. I'm not exactly sure when the first PAR 64 lamp was introduced. I started trying to find that to find definitive proof of the first PAR 64 lamp. And then I realized that that was the path to madness, and I could just say, I'm not sure. I did my best. Before coming to my senses, though, I did find a patent from 1921 filed by Hereward Lester Cook with a filament enclosed in an envelope that includes a paraboloid reflector on the back and a lens on the front designed to further direct the light. And another patent from 1938 discussing how to fuse those two together so that the reflective coating could be applied without worrying about getting it on the lens or the filament or any of that stuff. These were intended for automotive use. The old round sealed beam headlights on a Volkswagen Beetle or Volkswagen Bus, those were 12-volt PAR 56 lamps. Those were made mandatory for all vehicles in the US in 1939 or 1940. I saw both years listed. Technology Connections has a much better video on those. Traffic lights look like they would be giant PAR lamps, but they're actually just a normal screw base lamp in front of a reflector behind a glass filter, at least until they were replaced with LEDs, of course. The earliest non-automotive mention I could find is from a 1949 ANC Landing Aids Experiment Station final report, which talks about using PAR 64 and PAR 56 lamps as runway lighting and lighting on aircraft for landing in bad weather. Hold on to that thought, we'll come back to it. The 1953 General Electric catalog has a 300-watt PAR 56 lamp listed, and the 1949 catalog does not. I wasn't able to find any of the catalogs between those 2 years, but somewhere in there, it was added to their inventory. I also found a September 1963 issue of Western Aerospace, formerly Western Aviation, Missiles and Space. That has an article talking about using Colortrans' new Lex 64 fixtures with a new Sylvania sealed beam halogen lamp, a quartz envelope with iodine inside it, with a tungsten filament that is inside the existing PAR 64 reflector and lens to form a very bright and explosion-proof light. They also talk about how they're available in a very narrow spot, a narrow spot, a medium flood, and a wide flood. It also told you how many you would need to get full lighting coverage of a missile 15 foot in diameter and 150 foot tall using narrow spot 1000-watt PAR 64 lamps. It's 162 on towable trailers or 153 on 50-foot towers, just in case you ever need that information. So the quartz halogen version of the lamp was introduced sometime around 1963, close enough that it was called New in a magazine from that year. Good enough. One thing I found interesting researching this was that I'd always viewed the PARcan and the PAR lamp as sort of primitive things, kind of crude, good for blasting light in a general direction, but nothing fancy, nothing intricate. But for a while there, they were literally aerospace technology, guiding planes in for safe landings in bad weather, and allowing us to get quality footage of cutting-edge rocketry experiments. Good work, little guy. Anyway, with our quartz halogen source and our 4 different beam widths, we have arrived at what is basically the modern PAR 64 lamp. It was introduced sometime around 1963, probably by Sylvania, in a form that would last for over 50 years. Good enough. Now, having mostly satisfied myself with the history of the PAR lamp, I next started looking for the history of the PAR fixture. First, I looked through the books and catalogs that I had on hand. My 1953 copy of Stagecraft and Scene Design by Herb Filippi does not mention PARcans, or PAR lamps, at all. And all the border lights he has are either they use standard light bulbs, which are an A or a PS shape, or a reflector flood, which is an R series. My 1958 copy of A Method of Lighting the Stage by Stanley McCandless has similar information. The Control Booth Forum provided a catalog from a company called Area Light from 1960 that's advertising a series of fixtures named PAR lighters, which are available in 64, 8-inch, 56, 7-inch, and 46, which would be 5 3/4, I think that's a typo, sizes. They max out at 500 watts though, and this appears to be before the introduction of the quartz halogen lamp. I found a 1963 catalog from the Little Stage Lighting that has a theatrical fixture that uses a PAR 64 lamp, and a lens, interestingly enough, like a second lens, for wash lighting. My 1967 copy of Lighting the Stage, Art and Practice by Willard F. Bellman does mention PAR lamps. And while he is complimentary towards their use in border lights, he then goes on to say, "The lighting artists with a limited budget is particularly warned against cut-rate spotlights and substitutes for spotlights using PAR or R-type reflector lamps. Such equipment is usually not worth the freight one must pay to get it." Dude, harsh. In 1968, Berkey Colortran introduced the Cinequeen, which was a fixture designed for TV and film that used a PAR 64 lamp and a fixture just large enough to mount it and attach a yoke to it. It's closer, but it's still more complicated than a can with a PAR in it. It's also kind of short, and if you used gel in it, it would be uncomfortably close to that lamp. I have an Altman catalog from 1969, and while it has a border light that uses either PAR 56 or PAR 64 lamps, it does not have any PARcans in it. We have some of those border lights here at work. They're 8 feet long. It's completely ridiculous. Although thankfully ours don't have the asbestos cords anymore. My 1967 copy of Theater Backstage from A to Z by Warren Lounsbury has PAR lamps in it. And says that they were invented by Clarence Birdseye. Yes, the frozen food guy. I looked through the patents, and Birdseye does have a lot of patents, and he did love inventing reflector lamps. But they all seem to be screw base lamps, so that may just be something apocryphal. It has pictures of several fixtures by Ariel Davis, a framing spotlight that has a lens and shutters, as well as the PAR lighters that we saw before. He's also more complimentary of them, praising them for their brightness, but admitting that the soft edges limit their use on stage. He also mentions that the larger PAR 64 framing spotlights have been discontinued, which I'm guessing is that unfortunate Little Stage Lighting fixture from 1963. The Strand Archive lists the PAR 64 PAR Blazer as originating in 1977, and CCT appears to have introduced the Rocket also in 1977, which tracked with James Thomas Engineering introducing their PAR bar in 1977. The rocket was the first early instrument I found that looked like what we normally imagine a PARcan looking like, a simple metal cylinder with a yoke. Although it does include a handle on the back, so you don't have to grab the back of the lamp, which would have been a nice feature to keep. And the pamphlet definitely feels like it was aimed at concerts more than theater, saying, "The rocket will blast a galaxy of color into your show," and praising its ruggedness and simplicity. I thought I'd found my origin. Then I read the rest of the pamphlet. If you are a road crew or a theater electrician, you will already know about PAR lamps, around which we have built your rocket, which implies that there were forerunners being used for this sort of thing that were pretty widely known. So I kept searching. It was around that time I found an article written by Michael Callahan for Lighting and Sound America, which would have been great to find before I did all of this. He states that Ariel Davis filed a patent with a PAR 56 instrument on an electric raceway with integral unistrut track for mounting them. They then moved into TV used in 6 and 9 light banks. Then, in 1971, Chris Langert used Cinequeens with glass filters to light the Moody Blues at Carnegie Hall, and more importantly, then had his class at NYU work on building a PARcan with a longer tube to keep the gel farther away from the lamp. Then John Tedesco, my apologies if I'm mispronouncing these names, who had also come to NYU, suggested the PAR 64 to Chip Munk for the 1972 Rolling Stones tour. Chip brought one of the short-barreled PARs to Altman and had them make 60 of them for the tour. John Tedesco then took PARcans on the Led Zeppelin tour that summer. Somewhere in there, Altman also lengthened their PARcan, and their steel cans dominated the American and British market until the Brits started making their own lightweight aluminum units. I also learned from this article that Graham Thomas of James Thomas Engineering originally built electric chicken coop heaters, but using a spun aluminum process that he would later use to make PARcans. JTE started in a garage in Bishopton, England, part of a proud tradition of innovations created by British men in a shed. JTE still makes truss to this day. Anyway, at this point, it looks like we've got a decent, if not perfectly documented timeline of the origin. The sealed beam PAR lamp was invented in 1921. It gets used in cars and then aircraft and then architectural lighting before moving on to television in the 1960s. In 1972, the television fixture gets simplified and lengthened, becoming the PARcan we knew and loved. The Americans start with steel ones, and the Brits start making their own aluminum ones. While the earliest widespread entertainment use of the PAR 64 lamp was in film and television, they really took off in rock and roll. PARcans were durable enough that angry roadies throwing them on and off of trucks didn't usually break them, and they were simple enough that if they did, you could usually fix the problem with a screwdriver, maybe a hammer. The Doof Warrior appreciates their reliable simplicity. When used in rock and roll, huge banks of PARcans would be mounted on towers, trusses, and bars, blasting the stages with colored light. Sometimes you would also have 4 28-volt aircraft lights, told you we'd come back to that, wired in series so that you could use them with 120-volt power. These were called ACL bars, or just ACLs, which aircraft light. These weren't usually used to light the performers directly, but to blast beams of light through the haze. And in the good old days, you didn't even need to rent a hazer because you could smoke indoors. You got your haze for free. You got all of your equipment cigarette scented for free. You got a vastly increased risk of lung cancer for free. You can still buy 28-volt incandescent aircraft lights. And there are entertainment fixtures that are called ACL bars. But the actual fixture is usually nowadays an LED source that's just been set up to produce that sort of thin beams of light effect without requiring you to wire things in series. Anyways, in addition to the ACLs, you'd have rows and rows of PARcans, and there would be colored gel in front of them, and they'd be flashing away. They were bright. These were 1,000-watt lamps, which was important when you wanted to use really saturated colors. As I mentioned in a previous video, some of those dark blue gels have single-digit transmission rates. But they were also really hot and power-hungry, and the urge to get away from that actually led to the introduction of moving lights. But that's a story for another time. So let's look a bit more closely at these lamps, the fixtures that they fit in, and how you work with them. As mentioned before, PAR lamps come in 4 different beam widths: very narrow, narrow, medium, and wide. They are sometimes marked on the back of the lamp, but those markings are usually burnt off by the intense heat that they generate, and really the best way to tell them apart is just look at the lens. Basically, the more stuff that happens on the lens, the wider the beam's going to be. A very narrow PAR has a clear lens. Nothing's happening. A narrow PAR has a frosted lens. A little bit more diffusion's going on. The medium and wide PARs both have a pattern of ridges. Annoyingly, they are the most common ones, and they are also the hardest to tell apart. Once again, the more stuff that happens, the wider the beam is. The lens ridges on the wide lamp are closer together than they are on the medium lamp. I can tell them apart by eye now, but when I was younger, I used to hold my finger up to the lens, and if the spacing was wider than my finger, it was a medium. If it was narrower than my finger, it was a wide. You may need to find a different technique if you don't have big fingers like I do. Now, you may be thinking to yourself, I thought I wasn't supposed to touch theater lamps. And that's generally true, but you can happily touch a PAR lamp. The original lamps had just the filament straight inside the glass lens and reflector combination. When they introduced the new quartz halogen lamps, they put the quartz envelope inside the original glass container. Sometimes it's a neat little double-ended package that looks kind of like a T-style lamp, and other times it's just the envelope of an FEL lamp mounted sideways. In any case, you can touch these all you want. And if you've got a lamp where you can actually get your fingers to the quartz part of it, you've got bigger problems. Focusing a PARcan is pretty easy. There is no focus knob. There are no shutters. There is no pattern slot. There is no accessory slot. You put a gel in it, and you point it at something. If you want to make a mostly futile attempt to control the spill, you can put like a top hat or some barn doors in it. But that's about it. You do need to rotate the lamp, though. A PAR lamp does not produce a circle of light. It produces an oval. And you can rotate the lamp to change the axis of that oval. You do this by putting on a thick glove, reaching into the back of the instrument, grabbing the back of the lamp, and brute forcing it into position. You are grabbing the back of a 1,000 watt lamp, so the glove is not optional. Also, sometimes it can be hard to get it to move, but remember, these are not fragile. You can hit them and swear a little bit. You're allowed to swear, it's theater. This is usually referred to as rotating the bottle, as you are rotating the quartz bottle that contains the filament. One of the designers who worked on rock and roll shows when these were, the rock and roll instrument, described their focus technique as they would blow a whistle, which would cause the board op to bring up a light, and then the electrician doing the focusing to move to the light that was on, and then they would stand where they wanted the light to be and hold out their arms, indicating how they wanted the bottle rotated. When they were satisfied with the focus, they would blow the whistle again, the board op would bring on the next light, and the electrician would move on to focus it. If you want to change the beam angle of a PARcan, you simply swap out the entire lamp. You open up the back of the instrument, you unplug the lamp. Keep in mind that if it's been on for a while, this will all be very hot. You remove the retaining clip. Now, depending on the manufacturer, these can be very stiff, so do not be afraid to get a pair of channel locks to help you get a grip on these things. Then you take out the old lamp, and as the good book says, installation is reverse of removal. Because the lamp contains the lens, filament, and reflector, PARcans are interchangeable to a degree really not found with any other theatrical instrument. We've got 4 different types in our inventory here that I know of. Now, they did have some problems. First off, they were an incandescent lamp, so mostly what they generated was heat. And since they started at 250 watts and were usually 1,000 watts, they generated a lot of heat. Now, you may be wondering, how hot could they possibly get? Well, the answer is this hot. Moving on, the connector on the back of the lamp, not that great either. The mogul end prong loves to bend and warp. The sockets will get damaged by the heat, the wires will fray and that shock the stagehands that forgot to wear their gloves, and sometimes they'll appear to be dead, only to suddenly spring to life when you give them a good smack. They were also physically large as well. A normal stage lamp came in a box that looked like that. A par lamp came in a box that looked like that. And if you needed to store a lot of par lamps, you wound up buying a drum like this one. And sometimes when the lamps would burn out, they would burst, shattering the heavy front lens and launching inches-long, razor-sharp, searing hot shards of glass out the front of the instrument. While that is metal as heck, and probably a Warhammer 40,000 weapon option, the performers did not appreciate that. Modern PARcans have a screen to catch the bigger pieces, but older ones didn't. You would sometimes improvise a safety screen by welding a piece of mesh to a gel frame, but it made it harder to get the gel frame into the instrument, and it would burn a waffle pattern into your gels. We used to have a couch here where one of the cushions had a crescent-shaped char mark on it from a fixture without a safety screen dropping a hunk of hot lens onto it. The final problem was that while the instruments were literally just a can, the lamps were actually quite difficult to manufacture. You had to cast 2 large pieces of glass, you had to put a reflective coating on one, you had to mount the quartz envelope inside it, and then you had to seal the 2 pieces together. They were more difficult to manufacture than any other commonly used stage lamp. And since rock and roll had ditched the power-hungry banks of PARcans in favor of moving lights, demand dropped. One by one, manufacturers stopped making par lamps. Finally, only Osram was left. Then, on March 25th, 2019, Osram announced a recall of 6-inch, 7-inch, and 8-inch par lamps, and most ominously said, "Unfortunately, we are unable to offer you a suitable replacement for these products. So instead, you will be reimbursed for the price you paid to purchase the product within reason." Then, on April 5th, 2019, they announced that they were ceasing manufacturing them altogether. The American factory had closed, and the overseas factory that they had been working with was not able to manufacture lamps to the safety standards that they required. Sadly, Osram had introduced a lamp called the Alupar, which instead of the tricky 2-part glass envelope, had a glass lens with an aluminum reflector clipped to it and a halogen lamp crimped into the back of the aluminum reflector. It was half the weight of a normal par lamp, and it could be much more easily recycled since you could just pop the various pieces apart. Unfortunately, it had been introduced many years previously when there was still a lot of competition amongst par lamp manufacturers, and by the time it would have been useful, they had discontinued it and sold the tooling for scrap. Then, on May 14th, 2019, Altman announced that they were ceasing manufacturing their PARcans. Nowadays, you can still find PAR 64 lamps for sale, but they've doubled in price, and given that Osram ceased working with the one company left that manufactured them because they weren't meeting their safety requirements, that may not be the wisest choice. They had a good run, but it's probably time to switch to LEDs if you want to just blast color at stuff. Their day may be past, but for a good couple of decades, these were rock and roll. It was a little weird doing one of these videos about a fixture that I used growing up. I mean, we still use some of them here. I mean, I guess it could be worse. I could be doing this about a fixture that I remember being introduced. Okay, well, that's all for now, and thanks for watching.